Well, hello everyone. This is KP the Math G, ready to do my 123rd calculus video. And I am very pleased to be able to do this problem here for you. The 2011 free response question number 6 is a function. It is, as you can tell, a piecewise function. F at x, for x less than or equal to 0, we have 1 minus 2 sine x, and e to the negative 4x for x greater than 0. Alright, so I'm going to do only A and B part. There's 3 parts to this, and I'm sure I would run out of time if I tried to do part C. I'm already ready to do part C right now, but I want us to be able to do A and B. And again, I try to pick problems that we have not seen, from me anyway. You've seen it probably time and again, but you haven't seen it from me, at least not that much at all. So that's why I want to present something like this. This is really good, and I want to show you these, at least the first 2, and then the next video, my 124th video, will be on the 3rd part of this. I'm really anxious to do all 3 parts of these, and let's go ahead and get started now. Again, the 2011 free response question number 6. This is the function, piecewise function. And the very first question is, show that, let's see how they word it, F is continuous. F is continuous at x equals 0. Now, to show continuity, you have 3 stages. First of all, remember. Alright, so we got to show, alright, first thing you got to show is that F at, well, let's just say this, yes. I've got to show that F at 0. Well, I need to see what F, and it says at x equals 0. Now F at 0, let's say it's equal to some number. We don't know. We're just going to make up a number. That's 12, and it's not 12, but let's say that it is. Then number 2, the limit as x approaches 0 from the left, F at x must equal the limit as x approaches 0 from the right, F at x. And by the way, they need to both be equal to 12. Then, of course, if F at 0 equals the limit as x approaches 0, F at x, that those 3 is what you have to prove when you are showing that this is that this F is continuous. Okay, and I don't want to go through the scenarios of one being true and the other one not being true, or 2 of them being true and the 3rd one not being true, or whatever. So we just need to go ahead and take a look at this. So keep in mind that if you deal with 0 from the left and 0 from the right, if they're the same number, then the limit does exist. We don't say left or right down here. Okay. This could be, this could be 11 and this could be 12. End of story. Okay, and if this does not exist from the start, forget it. Stop. Just say it does not exist at f at 0. Now, you have to be careful. Let's go ahead and talk about f at 0. It's not 12. It's something else. Okay? You look for the equal. You don't have to deal with both of these. Okay? You're taking a time test. So you don't have to deal with both of these. Look for the one that says equal to, and that's going to be this one here. This one right here. Okay, so 1 minus 2 sine of 0. Alright, now sine of 0, you have to remember from the graph. I always like to, there's the graph of sine. So sine of 0 is 0. So 1 minus 2 times 0 is 1 minus 0, which is 1. So f at 0 is equal to 1. Alright, so that's what you do. You just plug it in. You don't have to do anything else. Just plug it in. Alright, so there it is. The second part. Let's look at the limit as x approaches 0 from the left. F at x. Now, from the left is the one that we're trying here. We've already seen that f at 0 is 1. So the limit is 1 minus 2 sine. Just simply plug the 0 in, and we already know that that limit, ooh, that is wrong. That is incorrect. You will get docked, or you will not get points if you leave off the limits. From the left, that's the reason we do that, is because it's less than 0. Greater than is from the right, less than is from the left. Alright, so now f at x, which is 1 minus 2 sine of x, like that. And then if you want to do this, the limit as x approaches 0 from the left, 1 minus 2 sine of 0 is equal to 1. So that limit is equal to 1. Alright, if you will, I'm going to go ahead and erase all of this, but just understand when you're looking from the left, you're looking at this one, less than 0. You know it is approaching 0, so you do plug the 0 in. Alright, so we know that this is equal to 1. Alright, now let's hope that the right side, or the right hand limit here, also equals 1, because if it does, then these two are equal, and then we have the third one automatically. Okay, so limit as x approaches 0 from the right, f at x, is equal to the limit as x approaches 0 from the right, e to the negative 4x. Alright, so all we're doing is plugging that in. The limit as x approaches 0 from the right. Alright, e to the negative 4 times 0. That's equal to e to the 1. Negative 4 times 0, well, that's actually 1. Negative 4 times 0 is 0, so the limit as x approaches 0 from the right, e to the 0, and that is equal to 1. Okay, so it does equal 1. So this limit as x approaches 0 from the right, f at x, is also equal to 1. Okay. Alright, so the third case then is then, therefore, number 3, Elf at 0. And you need to show this and say now, you don't have to say left or right anymore. X approaches 0. So we can just say now the limit as x approaches 0, no plus, no negative, f at x equals 1. So f at x equals 1. Therefore, f is continuous. Alright? F is continuous at x equals 0. Alright, and that's what you got to do. Okay, one thing that I want you to look at is this. We could have, and I said I wasn't going to do it, but I'm going to go ahead and do it anyway. But we could have the following scenarios. We could have, let's say we have this piecewise function, well, let's say xy. Alright, and I know that it goes on this way as well. Okay. We have something coming this way, alright, or let's say here's maybe 2 or something, 1, 2, and then f at 2, alright. So f at 2 happens to be here, alright, but then this is, let's say maybe this is 2 also, alright, and then the limit as x approaches to the left, this is, that limit exists, it is 1, and that you can just stop right there. Limit from the right, no matter what it looks like, it is also 1, but those limits do not, there is no continuity, there is a hole here, alright, f has a hole, alright, and even though f at x does exist, and even though the limits both exist, the third one fails simply because f at 2 does not equal the limit as x approaches 2 f at x. Okay, and I'm using 2 instead of 0, but that's okay. Alright, you could have this existing. Let's say if this were solid right here, but for some odd reason this one is right here going this way. That's a jump there, right there. The limit exists from the left and from the right. F at 2 is equal to 1 in this case, but the limit from the left, the limit as x approaches 2, let's say it's called f, from the left is 1, but the limit as x approaches 2 from the right, f at x, is not 1. It still exists, even though it's hollow. You still approach it, it's still 2. Okay, right there. Alright. That's a bad case scenario too. I mean, you have this existing, this good, oh no, okay, not good. Alright, like that. But then again, if, even though the limits exist, we can have this right here and have something like that, and f at 2, well, what is it? Does, oh, we say D and E, does not exist. The limit can exist with a hollow circle, but f at 2 needs to be solid. Where is the solid circle? You do not have it. You can stop right there and say, well, because f at 2 does not exist, and that's what we say, D and E does not exist, it's over. Okay, it's all over. Okay, And that, I mean, limit is probably something you did at the very beginning of the year. Maybe you have kind of forgotten a little bit about continuity here. So that's the scenarios that you can be faced with. All right. We do need to move on. So let's go ahead and get, it says for x not equal to 0. For x not equal to 0. All right, so we need to express f prime at x as a piecewise function. PW is piecewise. Okay. And then find the value of x. And we're just going to say f prime at x. So I'm going to move along, see if we can, oh, -3, my bad, -3. -3. Okay. I had to study this a little bit, but this is all you're doing. You're just taking the derivative of f prime. F prime at x is, well, we're looking at, for x less than or equal to 0, we're looking at this derivative. For x greater than 0, we're looking at this derivative. All right, so let's do this derivative here, f prime at x. All right, now let's think about this. The derivative of 1 is 0 minus, okay, now the derivative of sine is cosine. The antiderivative of sine is negative cosine, but the derivative of sine is cosine, negative cosine x, for x less than or equal to 0. All right. All right, then the second part of this is e. Let's see now. E to the negative 4x. Let's put this off to the side. E to the negative 4x. The derivative of that. All right. Well, that looks tacky. All right. The derivative of this is equal to. Now remember, e to the u is just e to the negative 4x. Now remember the chain rule. You got to remember that you got to multiply by, well, the derivative of negative 4x is just negative 4. So negative 4 e to the negative 4x. All right, so negative 4 e to the negative 4x, for x being greater than 0. And what they're trying to do here, they're just trying to get you to see if you know how to find the derivative. You still got to remember the derivative of sine and cosine and tangent and so on. You still got to know the derivative of e to some function or some exponent. Okay, I say function, but some exponent, exponential there. Okay, there's that. That's the first part. Now f prime. Let's see, what does it say now? It says f prime at x equals -3. Now, here's the deal. We have to set these equal to -3 and see what happens. Let's take the first one here. So that's, we can disregard the 0. So -2 cosine of x. And let's see here. Yeah, all right. So -2 cosine x is equal to -3. When we divide by -2, guess what we get here? Cosine x is equal to 3 over 2, positive 3 over 2. Now, that is greater than 1. And that's important because when you think about the graph, okay, when you think about this graph, 3/2 is 1.5, isn't it? So when you think of the graph of cosine, here's 1, and the same is true of sine. It starts up here, it does that. Alright, so 1.5 is up here. There is no graph up here. 1.5 here where 3/2 is. Okay, so that does not, we don't have graph here. So that does not work for x less than or equal to 0. Alright, so we have to set it equal to -3 over here. Alright, so that does not work. So we can say then that -2 cosine x is not equal to -3. It cannot be. Alright, and so that's what, and it's for all values, for all values less than 0. Alright, so less than or equal to 0. Okay. Alright, right there. That does not work there. And they just want to make sure you understand that that does not work there on this one. But this one does. So here we go. Let's get a different color because I'm sure that green is kind of light. So let's do this. The same thing. I want to go ahead and put this, make sure you have this down right here. Okay, I'm going to erase this, and I'm going to do this side here, -4. So -4 e to the -4x is equal to -3. Again, this is time, so we can divide by -4. -4 on both sides. So e to the -4x is equal to +3/4. That's good. Now I can introduce ln on both sides. ln e to the -4x is equal to ln 3/4. Okay, like that. And now -4x. Let's see. Let's write this on the other side. ln e to the -4x is equal to ln 3/4. I need some room to work. ln e, what was it? Let me read it again. ln e to the -4x, yes. E to the -4x is equal to ln, I want to say this is 3/4. And that's good because ln is positive. ln cannot be negative, otherwise we are really in trouble. Alright, so let's see, I'm making sure I got everything right. Okay, that is. So now the ln and e, just bring it down to -4x is equal to ln 3/4. Multiply both sides by -1/4. Alright, -1/4 on this side. So x is equal to -1/4 ln 3/4. Okay, that's going to be okay right there. Alright, and so the conclusion is that this does -4 e to the -4x does equal -3 for x, for all x greater than 0. Alright, and that's all that we have to do with that. Well, and then show that x is equal to -1/4. Alright. 3/4. Okay. My goodness. Alright. There it is right there. Alright, I think that's all you have to show on that. And we can even say for, alright, on the interval right here. Alright, there it is. That's what you got to show right there. And I do not have time to do, I really would like to have more time to do part C because we're going to need it. Okay, basically we are going to need it. And my camera is not going to be able to take on too much more time in the first place. Okay, this is an old camera. It lasts for, it will go with me for almost 32 minutes. Sometimes I'm lucky enough to get 32 minutes in. So we're not going to have time. It's just not going to be enough. But this will be enough to show you right here. Understand what the rules are for continuity, like I just showed you on the first problem. part A, and then be able to find derivatives. If you have a piecewise function, you're going to have, when you take the derivative of f, you got to still have a piecewise function. Okay, just like we showed over here a while ago, there is your piecewise function. This is what you start with, but f prime is this, and still the same thing going here with x. Okay. All right. This is KP the Math G. Please, if you haven't subscribed already, please do so. If you'd like to make a comment on this video, please do so. I would like to see what you have to, or read what you have to say about the video itself. And then, thirdly, if you like to hit that like button, I appreciate every one of you. And I know that many of you are going to be taking this test pretty soon. Those of you who are in calculus, you just need to keep on learning, reviewing over continuity and your derivatives. Okay, this is KP the Math G signing off. Ladies and gentlemen, have a great day.